5713. Which statement is true about an autorotative descent? A. Generally, only the cyclic control is used to make turns. B. The pilot should use the collective pitch control to control the rate of descent. C. The rotor RPM will tend to decrease if a tight turn is made with a heavily loaded helicopter. The correct answer is A. Use cyclic control exclusively while turning during an autorotative descent in general. When anti-torque pedals are used to assist or speed the turn, especially when the left pedal is employed, the airspeed decreases and the nose pitches downward. When the autorotation starts, there should be enough right pedal pressure applied to keep the aircraft flying straight and avoid yawing to the left. To help the turn, this pressure shouldn't be adjusted. 5715. Using left pedal to assist a left turn during an autorotative descent will probably cause the rotor RPM to A. Increase and the airspeed to decrease. B. Decrease and the aircraft nose to pitch down. C. Increase and the aircraft nose to pitch down. The correct answer is C. An autorotative descent refers to a controlled and aggressive descent maneuver in a helicopter. During such a descent, the pilot may use left pedal input to assist in making a left turn while descending. When left pedal is applied, it increases the pitch of the tail rotor blades, which generates a greater thrust on the left side of the helicopter. This increased thrust causes a yawing motion, turning the helicopter to the left. Applying left pedal in this situation will result in an increase in rotor RPM. This is because the increased thrust on the left side of the helicopter causes a higher load on the rotor system, requiring the engine to produce more power to maintain the RPM. Additionally, the left pedal input will cause the aircraft nose to pitch down. This occurs because the increased left thrust from the tail rotor induces a rolling motion, and the resulting aerodynamic forces contribute to a nose-down pitching moment. 5716. When planning slope operations, only slopes of 5 degrees gradient or less should be considered, primarily because A. Ground effect is lost on slopes of steeper gradient. B. Downwash turbulence is more severe on slopes of steeper gradient. C. Most helicopters are not designed for operations on slopes of steeper gradient. The correct answer is C. Helicopters have specific limitations and operating capabilities, and not all helicopters are designed or certified for operations on steep slopes. The design and construction of helicopters are primarily optimized for level or relatively flat surfaces. Slopes with gradients steeper than 5 degrees can pose significant challenges and risks for helicopter operations. In such conditions, the helicopter may encounter difficulties in maintaining stability, rotor clearance, or effective control. 5714. Using right pedal to assist a right turn during an autorotative descent will probably result in what actions? A. A decrease in rotor RPM, pitch up of the nose, decrease in sink rate, and increase in indicated airspeed. B. An increase in rotor RPM, pitch up of the nose, decrease in sink rate, and increase in indicated airspeed. C. An increase in rotor RPM, pitch down of the nose, increase in sink rate, and decrease in indicated airspeed. The correct answer is C. The nose may pitch down, the sink rate may rise, and the apparent airspeed may decrease if the right pedal is used to help a right turn during an autorotative descent. 5717. When making a slope landing, the cyclic pitch control should be used to A. Lower the downslope skid to the ground. B. Hold the upslope skid against the slope. C. Place the rotor disc parallel to the slope. The correct answer is B. During a slope landing, it is essential to maintain the helicopter's stability and prevent it from sliding or rolling down the slope. To achieve this, the cyclic pitch control is used to hold the upslope skid, the skid on the higher side of the slope, against the slope surface. By applying cyclic input in the appropriate direction, the pilot can tilt the rotor disc and use the rotor's thrust to counteract the downslope component. This action helps keep the helicopter balanced on the slope and prevents it from sliding or tipping downslope.